Good morning, sir.
Yeah, good morning, everyone. Are you all able to see my screen as well?
Yes,
Yes,
sir.
sir.
Sure, okay. All right, so yesterday we worked with files, and we saw that files are another type of objects in Python. And files are a central resource for storing data and capturing the analysis of our problems. Okay, so any program we write might need to read the information from some file. Similarly, any analysis we perform in the program must need to be saved somewhere. So in order to save, we use a file to save the results. So files are very useful, and we must know everything about files. So yesterday we saw the utilities that Python offers us for working with files. Files are again an object in Python, and Python presents us with some methods that we can use to work with files. Using these methods, now we can read any file, whether it's a text file or binary file. We can specify the type of the file, and then we can also write to the file. It can be, we can write a text file. We can also write some byte code. Okay, that is binary data can also be written. Okay, usually we want to write some text data. Or let's say you're creating some machine learning model. You may be doing this in your later semesters. These models are not in text format, but they are in binary format. So when you want to save a machine learning model so that you can use the machine learning model later on, then you should save the machine learning model in a binary file. So there you will use the permission as write permission plus file format is binary. Okay, so this pretty much what we have done yesterday. The session we had, hands-on session demo we had yesterday, pretty much covers everything there is to know about files. There's really nothing more that is to do with files. Okay, so there may be a lot of topics, like while opening this, reading files, reading binary files, writing files, writing strings, writing lists, everything. But all this are just like, basically can be condensed to what we did yesterday. Okay, so that is the basics of files, entire basics of files. So be sure to master those basics. And once you go over them 2 times, 3 times, as one of you said yesterday, we need more practice, isn't it? Only with practice the learning happens. Okay, so I can introduce and demo and we can do a hands-on, but the learning happens with you. Okay, so let me again repeat that. So you do the learning, and so therefore the materials are available. Be sure to master the basics of files. It's just like 1 hour session we had yesterday, that's all, and you master that, and you can work with any sort of files, okay, in Python, okay, here after that. All right, so are there any doubts from yesterday's session? Anyone has any questions? Are you all able to hear me?
Yes, sir.
Okay, okay. All right. So if there are any questions about files, please post it. I'm sure we require some more time to practice with files. But if there are no questions, we'll do another exercise today. Okay. What we will do today is we saw about exceptions last week, and I want to continue that discussion a little bit. So we saw all the types of exceptions, and we saw how to write code that can handle potential problems in our program. Okay, so whenever we think that some code in the program may raise some errors, then what we do, we just put it in a try block. Try to execute the statement, Python. Okay, and if you're not able to execute the statement, go to the except block and do what is there in the except block. Okay, and this we saw last week, and I hope all of you again attempted the hands-on practice, the script for the sessions. what we will do today is write our own exception. Okay, so the new thing we'll be doing today is writing our own exception. Okay, so we can define our own errors. Okay, so all of us are in different domains, isn't it? Okay, so Python is just a programming language. It's a language to work with computers, and computers are used in every discipline, isn't it? What is it? Let it be like artificial intelligence, computer engineering, electrical engineering, mechanical engineering, data science, biotechnology. Every field is being used in a big way. Even in biotechnology, it's being used in a very big way. So Python is a tool for us, and we need to use this tool in different domains. Okay, and the errors that Python usually returns us are very specific, general purpose errors. Okay, so the errors that it returns are like name error, value error, okay, type error. These are the general sorts of errors. So these are to do with the Python data structures themselves. But in our particular domains, we may expect the data in a certain format, and if the user doesn't provide the data in that format, we would like to raise a error. Okay, so we would like a set of exceptions for our own domains, so that when people use our programs, when let's say biologists are using a biotechnology program, the error messages that are returned are very specific to the discipline. Okay, like if a someone wants to use a robot design program, then you have some specific errors you have in mind. Let's say the let's say the interface between the arm and the head. Okay, so let's say the interface between the ear and the head is not good. So there's an interface error. Something you have to say, isn't it? No, I'm not an expert in robot. I don't know anything about robotics. But let's say you're trying to design a robot, and there'll be a lot of series of errors that you can provide for the user in guiding them to design a better robot. Okay, so these exceptions are not errors that are already raised by Python. Okay, Python has only a very few set of basic errors, exceptions that it can identify. So in our own particular domain, we have a need to show these particular errors. So how do we code our own errors? Then we can check for these errors. Is that right? So that is something we would like to do. We would like to create our own exceptions, especially since we are from diverse backgrounds, and then use these exceptions in our particular robot design program, or sequence design program, or structure design program, or let's say some artificial intelligence. You want data to be in a certain format, whatever it may be. I want to raise my own exceptions. So how do I create my own exceptions? That's the subject of today's class. All right. So let's see how to create our own exceptions. All right, so all of you, I hope you are with your idle on. So we're going to do this hands-on. I'm going to open a new script. So as I said, all these exceptions that are raised, they are themselves objects. The exceptions themselves are objects. So everything in Python mostly is the object. Okay. So the file was the object. Now we see that the exceptions are also objects. Okay. So all exceptions belong to a base exception class. Okay. And they are subclass of the exception class. Okay, so when we want to write our own exception, we have to inherit from the exception class. All right, so let's see how to do this. So we want to create our own exception. So what we do is we define an exception class, because exceptions are objects. So we say class, I want to create my own exception by exception. So this derives from the base exception class. Okay. So there is a exception class that is defined in the Python language itself. Okay, and any exception should ultimately inherit from this base exception class. Okay, so that's why we are putting it here to indicate inheritance. Now all you need to do is just create this class, and this class already inherits from exception, so it is known that it is a exception. Okay, and exceptions basically halt the execution of the program. So there needs to be no code inside the exception, but you can't have an empty class, just like you can't have an empty dictionary, empty function. So what is the keyword we can use instead of leaving it empty? Excellent. So we can say pass. Okay. All we need to do is create an exception class that inherits ultimately from the base exception. No other code needs to be written. Okay. We just want to indicate that this is my own exception. You can give a much more informative one. We'll do that shortly. Okay. And all we say here is pass, meaning that the class has been instantiated. All right. All right. So this is what we do. So what we'll say here is class my exception and exception, and we say pass. Right. So now what we will do is, let's say that we'll take some input from the user. Let's say x is equal to, let's say, for a change, we'll work with, let's say we work with some sequence, some string sequence. Let's say it's a DNA sequence. All of us know about DNA. It's nothing to do with, it's elementary biology. So there's no harm in working with DNA sequences. So what I will say is, let's say we have a string, some sequence, and the sequence is actually a DNA sequence. And let's say we take it as input from the user. Input, enter a sequence. And here it can be a DNA sequence. Whatever, will come to that in a while. Okay. And now we say is, and we'll say if len of seq, I want the sequence to be at least 10 characters. Okay, let's say that the sequence has to be at least 10 characters. And if say the len of seq is less than 10, I'll say I can raise my exception. Okay. Let's say just print sec here. Make sure the command is working. Okay, we raise my exception, and we can say this is the error message to be displayed. Sequence should be at least 10 characters. Okay, and then else will print the sequence. All right, so this is what we have. Okay, and so let's try to run this. So what I'm doing here is I'm basically trying to illustrate how this class that we have defined here can be used. So I'm saying, like, let's take a sequence from the user and checking some input validation. Okay, so this is called as input validation. So let's do some input validation, isn't it? So whatever the input that we receive from the user must be validated to be in the right format, has the right things, has the right length, has the right type. Okay, and if you're saying int of input, it should be a number. So there's a lot of input validation to be done. And if you're processing a file for input, then again you may say that the data in the file should be in a specified format, and again you have to validate the input file. So it's a very common task in data science. So let's say we want to do some input validation, and the length of the sequence should be at least 10 characters. Okay, so now I check if the length is less than 10, I raise my own exception. So as I said, the raise takes a exception object, and my exception is the object that I'm raising here. I'm raising an instance of my exception class. And once this is done, this error message will also be printed, and the program execution will be halted. Okay. So if it's not halted, I can print. I don't want else. The program execution is not halted. Let it print the sequence. Otherwise, it will not print the sequence. So let it be. Let this be the logic of the program. And let's try to run this particular exception example. And what we will do is all right, so it says enter a sequence. So let's say I'm just entering some sequence now. Okay, and how long is the sequence? It's 8 characters. Let's see what happens. So now you see it doesn't print the sequence. It doesn't go to the print statement at all. it has come to the raise my exception, and my exception is the name of the error that has been raised, and the error message sequence should be at least 10 characters. This is how it has executed. Okay, so this is the behavior of the program. Okay, and this is how the interpreter works with the program, and it has raised the exception. Okay, now if you gave some other thing here, isn't it? Suppose like you just said, isn't it? Let's say you say you will not inherit from the exception. You just say class some exception and no inheritance. No, it's not a exception class at all. And this is what you're saying. Let's see what happens now. You see, it says something here, but the exception is not raised. Okay, so the exception is not raised, but the raise command still halts the execution of the program. Okay, so and there is no traceback that is printed. Okay, so this is what happens. Now let's see if so. Let's not now play anymore with these. We'll just have it as my exception. And now what we will do is now I'll give a proper sequence that is at least 10 characters. You see it prints the sequence and then exits. All right. So all right. So I hope that is very clear. You know how we create an exception class, and all you have to do is raise the my exception. Okay. Now this is very limited in use for us because all we have done is created a new exception class. Now we have to use this exception class within our program and handle the new exceptions that we arise. So let's say, going back to my example of a DNA sequence, let's say I want to receive an input from the user. Can anyone tell me what is the DNA alphabet? What is the DNA alphabet? What are the characters we will use in a DNA sequence? Anyone?
ATGC.
Okay, okay. ATGC, everyone knows that, isn't it? Okay, so just to place this on a very concrete basis, let's take a specific example of just a DNA sequence that all of us know from 10th standard biology. Okay, so DNA is composed of the letters. What are the letters? A, E, G, and C. Okay, now let's say I want to receive an input from the user, a DNA sequence. It's a very common task, and I want to check whether the input sequence is in the DNA alphabet or not. If the input sequence contains a character that is not A, T, G, or C, then I want to raise the error and tell the user that the input they have entered is invalid, and give the user another chance to enter a valid DNA sequence. Okay, is the problem clear to everyone?
Yes, sir.
Okay, great. All right. So for this, what I'm going to do is, okay, so we'll start a program from here. I'll say class, let's say this is not DNA. Okay, it's called class not DNA. That's the name of the exception, and it inherits from the base exception class. We already saw that this is very necessary to give. All I need to do is just create this class and then say pass. Now I'll create a function that takes a sequence as input and checks whether the sequence is in DNA alphabet or not. Okay, and if the sequence is not in DNA alphabet, the function should raise the not DNA exception. Okay, so what I want to do is def check DNA function. It takes two inputs. It just takes one input, that is the input sequence. Okay, and what does it do? Checks whether seq is a DNA sequence. What do we mean by that? That is in the DNA alphabet, which is AGGC. Okay, that's the alphabet, isn't it? Okay. Otherwise, raise not DNA exception. Okay. So this is what we wanted. So this is my function. Okay. All right. Now, how will I code this function? Any ideas? I have to check what is my goal in this program, in this function. I have to take each character from the sequence and make sure that character is A, G, T, or C. Correct?
Sir, A, T, G, and C can be declared as a list.
Yeah.
Then after that, for X in the sequence, then we will check if X in the list or if X
Correct.
not in the list, we will raise the exception.
Good, good. Okay. Let's do that. All right. So let's say, in fact, we can call this as a alphabet error, isn't it? Let's just say it's a, let me not just work with DNA. Let's just say it's an alphabet error, more general. Let's call it as a alphabet error. We have some alphabet and we want to find out whether the input sequence is in the alphabet or not. Okay. Otherwise, raise alphabet error. Okay. All right. So this is the alphabet. You can change the alphabet. Okay. Maybe suppose you are working with the RNA sequence, the alphabet will be A, G, U, and C. If you're working with protein sequences, the alphabet will be the 20 amino acids. If you're working in some other field, if it's not biotechnology, most of us are not in biotechnology, still you may work with sequences, and those sequences will have an alphabet. And sometimes you will need to validate the input given by a user so that it belongs in the alphabet. So it's a very general problem. So here we're just like, to put the problem on a firmer basis, we are saying, let's check for DNA alphabet. So let's say this is the alphabet. Okay, so now what I do is, I want to take every letter in the sequence. So we say for, okay, for letter in sequence, if letter, what do I say?
In, sir, letter in.
Okay, if letter is inside the alphabet, it is fine. Only if it's not in the alphabet, okay, I have to raise the error. I say raise. What do I raise?
Alphabet error.
Excellent. So raise alphabet error. Okay. Okay. Now, what is my next statement? So I'm moving letter by letter in the sequence. Every letter I'm checking if it's in the alphabet. If not, I raise the alphabet error. So what is the next step?
Break, sir.
Break. Okay. Actually, when it raises the alphabet error, it just halts the execution of the program. So we have to let the for loop go to completion. If the for loop goes to completion, what does it mean?
All letters are valid.
All letters are valid. Excellent. Okay. So that's all we need to know. Okay. We want to move letter by letter in the sequence. Each letter we are checking whether it's in the alphabet. If not for that letter, even if one single letter is not there in the alphabet, for the first letter, we raise the alphabet error and halt the execution of the program. Okay. That is the function of this particular function. Okay. So, but when we move through all the letters and all the letters are fine and every letter has been checked, no alphabet error raised, then basically that means all the letters are valid. So we have to just wait for the completion of the loop. And once the loop is completed, so I indent back to the loop structure here, and if the loop is complete, it is fine. So then what I can say is, I say return true, or I can return 1. Okay, there are many values in Python that all have the Boolean value true, isn't it? Okay, so let's just say return true, because this is like a question. Check DNA. Okay, is it DNA? Okay, check DNA. It is true, so that is what I return. Okay, but if there's a problem, it raises the error itself in all the execution of the program. So this logic is fine. Is that clear to everyone? Why we have a return true here? The for loop goes to completion. All the letters are valid. So check DNA, I return true. Fine. Anyone has any questions on that? This is just my simple function to check whether a given sequence conforms to the alphabet or not. I have a preset alphabet. In fact, this alphabet can be declared outside somewhere. Okay, because this alphabet is a constant. Okay, so I have this alphabet and I'm checking whether every letter in the sequence that has been entered conforms to the alphabet. If not, I raise the alphabet error right then and there. So that's fine, correct?
Sir, but we are not mentioning anything. If there is an error, we are not saying anything to the user.
That is right. That is what that now we will do. This is just a function to catch the error. Now we use the function in our program. We are coming to that. Okay, we are doing it step by step. We are breaking it down into functions, classes, and the program itself, main program. So in the main program, we'll receive a sequence from the user. We will call this function on the received sequence on the input, and we'll try to call the function. And if the function raises the error, we will handle the error. We'll do that now. Okay.
Okay, sir.
Okay. So now what we do is, so we're just coming to that. I'm a bit slow, I guess. All right. So let's say sequence. Okay, that's what we have earlier as well. Input, enter a DNA sequence. Okay. Now, there may not be any error in just reading the sequence. But now I want to call the function check DNA on the sequence. And this may be problematic because the check DNA may raise a alphabet error. With that, the program execution will get halted also. So therefore, there could be a problem. Okay. So you see this raise alphabet error is the class object, isn't it? So I have to instantiate like this. So raise alphabet error off. All right. So now what do we do is we'll say we have to put that within the try block. I want to try checking the DNA. So try check DNA of what? Of the entered sequence. Good. Try checking the DNA. Run that function on the sequence. Okay, I want to try that. Is it going to raise the error or not? If it's all fine, it will be true and it will exit the try and you go to the next one. Okay. Otherwise, if there's a alphabet error, you can say accept alphabet error or just accept, because the only problem here, the check can only raise alphabet error. So by default, it is implicit that it's only alphabet error. But we can anyway specify that. Accept alphabet error. There's an alphabet error, isn't there? Okay. Then I want to, what do I want to say? Print. How do I want to handle the error? One of you said we're not doing anything for the user. So what shall we do for the user? Any ideas?
Give another chance to type.
Very good. Let's give another chance to the user. Okay. So to give another chance to the user, what we have to do is we'll put this input also within the try. Okay. Now because we want to again read the input sequence. And then what do we have to do is we'll say while true. Okay. We'll put it within a while true loop. And I've again indented this region as one code block. While true, try taking the sequence and checking it whether it's in DNA except alphabet error. Now I want to say print enter a valid sequence. Okay. We can also print the base that is not here, and we can say how do we print the base? Okay, and we can say so not found on alphabet, and then we can say letter. Okay. All right. So now we say print enter a valid sequence. So this alphabet error can take a string as its argument, and whatever string is printed as the error message. Okay, and here what we are doing is we want to say print enter a valid sequence, and then again go back to the loop. All right. So now we can also say once it's all fine, we can say else print valid sequence. What shall we say? Has been entered. Isn't it? Okay. If it's try and there is no except, it comes to else, and in the else we can say print valid sequence has been entered. You see, the else can be used as if then else, also in the try except else. These are multiple uses of the else statement. Here also it is valid. All right. So okay. All right. So okay. So let's also say return. We can just return letter. And what we will do is the last letter in the sequence will be returned. Any letter is true. So what we have to do is we'll say some letter equal to check DNA sequence. And here again we can say this letter. All right. Okay, so now let's try to run this. So we are now handling the error. I'm receiving a sequence from the user. I'm calling the check DNA function and seeing whether it is in the alphabet. And if it's not in the alphabet, it will go to the alphabet error and it says print enter a valid sequence. And again, it goes back to the while true, which is the infinite loop, and it keeps doing this. All right. So if the true is successful, if the try is successful, I need to break out of this and I will break it in this way. Okay. As one of you said, for the infinite loop, if the try is successful, the last statement is always break so that it doesn't keep going inside the while loop. So if it breaks, it comes to the else, prints valid sequence, and then comes out of it. Okay. All right. So this is the code. Is this clear to everyone? We have created our own exception. We have done a function to raise our.
Why we are specifying in try letter equal to check DNA of sequence, sir? The same letter in the sequence.
Sorry?
No, that is what a letter equal to check DNA of sequence. That line I can't understand.
Okay. You understand why we are calling the function?
Yes, sir.
Okay. Now, let's say I want to I want to give a very informative message to the user. Let's say this informative message is there is some letter that is not there in the alphabet. The user would like to know what is this letter that is not there in the alphabet. So I need some way to grab this letter, and I'm doing that within the function. How am I doing it? If the letter is not there in the alphabet, this alphabet error will be raised. Correct.
Yes,
And
sir.
yeah, when it is raised, this letter value will be let's see if it is returned. And if it is returned, okay, and this is what we have.
This letter will be the returned value of the letter, sir.
Yeah, that's what we have to check. We'll see that it's experimental. It's even for me, it's
Okay.
still experimental.
Okay,
If the
sir.
letter, yeah, if it comes to this return letter, it's going to halt right here, isn't it? Okay. And if that is the case, then the letter will not be returned. This letter will also be an exception object because it is returning an exception here. And then when we are trying to print an exception object here, there may be a problem here. But if the letter is actually returned, then we are doing something even more useful. We're actually telling the user what is the letter in the sequence that does not conform to the alphabet. If this does not work, we'll again edit the sequence here and see how we can make it. We can make changes so that we actually return the letter as well. Okay, so that's what we are going to do. We're going to do a incremental debugging. Okay, which is always what we do. Okay, so this will be a session on debugging as well. All right, so let's save this. All right, so now it's asking me for some sequence. Now, actually, we didn't convert the sequence into uppercase. But ATGC is in uppercase. So all of you enter the sequence in uppercase. So let's say ATGC. ATGC. Here I put a S. I have a S here. Okay, S here. And then I'm going to again say ATGGGCCCTT something and all. All right. So let's see what happens. Now again it has come to enter a DNA sequence because it is erroneous. But it has printed the entire sequence. Let's see why it is printing the entire sequence. So it has said enter a DNA sequence. Okay. Oh, only now it's coming to the DNA sequence. I'm sorry. Oh, this whole thing is now also executing. Okay. Let us just comment out this region. Okay, now let's do this again. So ATGC something and all. I put a S here and then ATGC. So now you see. So first it raises the alphabet error, not found in alphabet S. You see the S is now printed. Okay. So during handling of the above exception, another exception occurred. Name error, name letter is not found. Okay, that is fine. The function itself returns the alphabet, so we don't have to put it here. All right, so this is for this error code we are giving here is already returning the letter. Okay, that's what it's saying. So the purpose is already served. Okay, so we've already done it. So therefore, we don't have to say letter equal to check DNA. You were right. So what we will do, we'll just take this out. And again, this letter is an exception object. Okay. I mean, the letter is not defined. Why is the letter not defined? Because the letter is not returned here. Okay. So therefore, the exception has been raised and nothing has been assigned to the letter on the left hand side. So therefore, letter is a name error. So therefore, we just. All right. So now this is going to work. There was just a small change in the program, and now we are confident that this is going to work. All right. So let me come out of this. All right. So let's again save and execute this. So enter a DNA sequence. Okay. ATGC, something. And then I put the S here again, and then some ATGC. Now enter a valid sequence. Okay. Now it's not printing my error message, alphabet error. This is the one problem. So enter a valid sequence. It's going to the exception, but it's not printing my raise the alphabet error. That is not getting printed. All right. Why is that not getting printed? All right. So it's not printing, letting us know that place. So once you took this out, letter equal to check DNA, and what has happened is again the letter it's not using this error message. Aha. Okay. Mm. All right. So. All right. Now let's give a valid DNA sequence. So now it has come outside the loop, but it's not printing. It is valid sequence has been entered. Uh-huh. Oh. Let's say only.
The break is
Yeah,
Come on.
it's coming out, isn't it?
Yeah.
Okay. So let's just put this here. Then it should work. I think only if the break is not there and the try is successful, it executes the else. With the break, it doesn't execute the else. All right, so that is clear because the break actually breaks outside the while true loop. It has nothing to do with the try and the except. That is the meaning of the break keyword. So break goes with the while statement. So that is fine. Now the only thing we need to find out is how to capture the error message is valid, because the error message does get printed here. When we have another exception, it is printed. But when there is no when there is no other problem like name error or anything, only the alphabet error, the error message, how do we catch the error message? That is a question mark. So you see it's working fine. Next time we do, it will also print valid sequence has been entered. Only thing is we want this to be more useful to the user. Rather than only giving the user another chance, we also want to point the user to the letter. And more usefully, if we can also indicate the position where the letter has been entered, that will be even more useful to the user. But before we come to that, we'll just see how to capture this error message alone. How do we capture this error message? Okay. What we will do, so this is some intricacy of Python programming. What we will do is we'll do a Google search. So capture error message in exception. Let's say this is Python. Okay, so I'm going to go to this. All right. Okay. Okay, it's exception as E. I have already tried this exception comma E, which used to work in Python 2.x. I wanted to see what will work in Python 3. This exception as E. All right. Okay, let's do this. So now I think we know how to do this. So as error message. Now there's an error message here. It seems that when we have this construct except alphabet error as error message, this entire error message is captured in this error message. So we can say plus error message. Okay. All right. Now let's see if this works. Okay. All right. Plus error message. So now let's enter a DNA sequence. Here is a S, and again a ATGCC, everything. All right, alphabet error, not found in alphabet, \s, okay. And then type error, cannot concatenate, not alphabet error. Oh, str, I'm sorry. Okay. We'll just say str of it. All right, so now let's run this again. So we have now debugged the code 2 times. So let's say T. Let's put a S. You see, now we get it. Enter a valid sequence not found in alphabet. S is there. Okay. Now there is some problem with what is actually printed. These are all small bugs. These can be easily fixed. But the main thing that is of use to the user, the erring letter. The erring letter has been printed. Now let's try another sequence. I'll put a C, G, and a E here, and let's see if the E is trapped. Now you see E is also written. Okay, so let me say U something here and then something, and let's see what happens. Not found U. Okay, now let's give a DNA sequence itself and let's see what happens. Valid sequence has been entered. Okay, is that clear to everyone how this is working?
Sir, I have a doubt.
Yes, please.
This will take out the invalid letters when, the first letters or continuous invalid letters. Like example, yes, it's taking out no, sir. Not
Yeah.
valid. It's showing. If there's another invalid letter, that will also be showed. Or
Yeah. Can anyone answer that question? See, this is the code we have. So what will the program do?
Sir, only for the first occurrence.
Only for the first occurrence. Good. You see, for the first occurrence that is not there in the alphabet, the error is raised. Only one alphabet, only one letter need not be in the alphabet. Even for that letter, the exception has been raised. And then again, it goes back into the loop. So the first time such a letter is encountered, when that letter is not there in the alphabet. The first time a letter is encountered that is not there in the alphabet, okay, the exception will be raised. And this will be executed and it will go back into the while true loop and again a try will be given. Is that fine?
Sir, but it
how
also
to
comes
do
under
that
the
for
logic.
reference of all the letters to find?
If you want to know all the letters, then that means there's a lot of problem in your sequence. So that you have to write another function for that. So that's a slightly different function again, isn't it? There you won't be raising a exception immediately. You'll first want to capture all the letters that are not there and then raise the exception. Okay, let's try your program. I think we have 10 more minutes. I'll take your suggestion and I'll implement your program. Any other questions, anyone? Any other questions? Someone else had a question? No?
Sir, actually, but that comes out of our logic, no, sir. Basically, that letter is not there, then there is not going to be DNA sequence.
Yeah. But let's make it more general. Let's try to implement your classmate's suggestion. I don't know her name, but it's we can do everything in programming. That's what I want to try and convey to you. There are no limits. Okay, so I'll take up the suggestion and we'll try to program that. Okay. Now we had a capital T there. That is because the tab space was not being read. It's a small t. Okay, so now the error will not raise. Now the other thing is we want to convert the sequence into uppercase. So let's just say upper of. Is it upper or two upper? Anyone recalls? Is it upper or two upper? To convert the string into uppercase? All right. All right, so now what I'm going to do is I'm going to capture all these letters as well as their index. Okay, so to capture the index, what I will do is, let's say this is the alphabet, let's say counter, or let's say index. Index is equal to 0. For letter in sequence, let's say index plus equal to 1. And if letter is not there in alphabet, what do? I say L1 let's say L dot append. Let's say we have a herring letters list. I create an empty list here. Sorry, not here. We do it outside. And here, what do I do? So in plus equal to 1, if letter not an alphabet, I say herring letters dot append of, I append, what do I append?
Letters.
Letter, and I also want to append the index, isn't it? How can I do that? Shall we do it as a tuple? Shall we append this tuple?
Yes, sir.
Okay. Now let's just let's say that I don't know whether the tuple can be appended to a list or not. Let's just check it in the console. Let's say L is equal to empty, and I say L dot append. One comma two, and I say L. 1 comma 2 is the element. So each element is a letter comma index pair. Okay. So let it be index comma letter. So now I am capturing both the index. You only wanted the letters, but here I'm making it even more useful. Let's say I want both the index and the letter. So I'm capturing both the index and the letter, and I'm appending to the list. So if letter not an alphabet, let's grow this particular thing. Okay. So let's finish processing the entire sequence, because we wanted everything, every herring letter to be captured. So it has to process the entire sequence and not raise an exception before the end of the sequence. So we have to let the for loop go to completion and let the herring letters list be completed. Okay. All right. Now what do we do? Anyone?
Check the length of herring letters.
Good, excellent. Who's giving these answers?
Venkatesh.
Venkatesh. Excellent, excellent, Venkatesh. We check len of herring letters. Excellent. So we check len of herring letters. If it's greater than 0, that means it has at least one herring letter. Okay. So if it's greater than 0, and what we say is, yeah, it's difficult to. All right. So we have to assign the list. Okay. All right. So if it's greater than 0, let's just return the list here, because we can't print all the letters. Actually, if you want only the letters, we can grow a string if you want. Okay. Otherwise, we have to return the list. Okay. Okay. We can raise the alphabet error, but the list may not be returned, because the alphabet error can only have an error message with it. It cannot accept a list as the argument. So let's say whether string of list will work.
Sir, inside this, if part we can write a print statement.
We can do a print within the excellent. We will do that. We can also do a str of list. That's excellent. Okay. So we can still use the. We can do a str. It works, Venkatesh. Even the str works. So let's do a str. Or as Venkatesh says, you can also print it within the thing. Okay. So yeah. All right. So raise alphabet error. And let's say. All right. Let's first try this. STR of varying letters. All right. Otherwise, we don't have to return anything. If we don't have a return statement, the function will return none. That is the default. So if len of varying letters greater than 0, raise alphabet error. Okay. So just to be safe, I'll just say return the same thing. Even if I don't say anything, it will return none. All right. So all right. Now I do a check DNA, and then if there's no error, I break and I say print valid sequence has been entered. If there's an alphabet error, I capture the error message here and I say plus. Okay. All right. All right, so this is what we have. Let's try to run this. Is this fine? Anyone sees any error in the code? Okay, so let's see. Let's try it out. Python interpreter is our final judge. So we'll do a. We can enter it in small case. Anything we can do. Now I'm putting a lot of bad characters. Now you see, enter a valid sequence not found in alphabet. At 6th position, we have a S. That is right. 7th, I have a D. 9th, F. So the whole thing is printed. And finally, it's asking me to enter a DNA sequence again. So let me just put something else again. So everything is invalid now. So you see, the DNA sequence did not evolve by chance because mostly it will be invalid. Okay. So now I just give a DNA sequence. Now it says valid sequence has been entered. Okay. So you see, we did a bit of googling as well, where we set the error. We used the as here and trapped the error here. And then we did a str of this error message because it is only a list. And with the str of the list, that also works. So we use the Google, we use the console, and then we debug the whole thing, isn't it? So this is usually how it works. You have to use the Python console, even when you're programming for small doubts that we have. The console is very useful. All right. So what has happened here is, and we can put a new line here because it was coming on the same line. So therefore, now this not found will come in the next line. Okay, I'm not going to do it, but you can try it. Let's do it. Why not? So not a valid, enter a valid sequence, not found in alphabet, all these things. So actually what we want to do is, let's first print this and then say enter a valid sequence, isn't it? Okay, plus, and then we need to put a \n, new line, enter a valid sequence. Now it is very user friendly, totally user friendly. Okay, so what it does is it converts to uppercase. If there's error, it gives the index and the letter, and it gives the indices and letters for all the erring letters. The whole thing is there. Okay, and it says enter a valid sequence, and again it gives another chance to the user. Okay. All right. Okay, we've done something in today's class. Do you all agree?
Yes, sir.
Okay, so I hope this has been clear to everyone. It may take you some more time to digest everything we've done today. Then iteratively, we built up our program from the scratch. We defined a very basic error class, and then we defined a function that does a few things, processes the input and validates the input. We put it in a while true infinite loop, and then we did this input validation till the user enters a valid DNA sequence. And this sort of coding is applicable, whatever the domain may be. You have some input, you have to perform input validation. It can be modeled on the same lines. First, write your error class, then write a function that checks the input validation and returns something useful for the user, and then do a try block with this function, call the function, and the error message is raised, and then print a useful diagnostic message for the user, and then give the user another chance to enter the valid input. And if everything goes right, print a message that the valid input has been entered, and then go on with the rest of your program. Okay. Questions, anyone? We have 1 more minute. So someone asked about the letters, all the letters. Is that fine now?
Yes, sir.
Okay, okay. So this is what you wanted, isn't it?
Yes, sir. Yes, sir.
Okay, okay. All right. Okay, any more questions, anyone? All right. In today's class, we use the DNA sequence example. The DNA is something we learn in 10th standard biology, so there's nothing really specific there. Okay, so most of the examples we do in class, all of them will be very general. Okay, and this is just like a one example to root our discussions firmly. And similarly, this can be extended, whatever the domain may be. Okay, and you want to perform some input validation. Let's say that input is a string. is some sequence, and then you have to model it on the same lines. Okay. All right. So I'll post all the materials in the class that we have done today. Okay. So with this, we wrap up our discussions of exception. Okay. So this is a very nice use case that we've studied about creating exceptions and using it for input validation. Like this, it can be used in many different scenarios. And do go over these while it's still fresh in your mind. At least do it at least one more time. And let's meet tomorrow again for a new class. Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Yeah. Thank you all. Have a nice day.
Thank you, sir.